Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 2 of lesson number 10, Gravitation. Now if you all remember, in part 1 we had the basic discussion for the lesson, that is basic discussion on gravitation. What exactly gravitation is, how exactly it functions, which are the different types of forces, what exactly the gravitational force does, different examples of gravitation, right? And about the story, like a short story on Newton, Sir Isaac Newton, on how exactly he came up with the idea of gravitation, right? So we have discussed all of that so far. Now, before I proceed with this part 2, I want each one of you to please revise whatever notes you have taken in your book. I hope every one of you are going through it. You need to revise each and everything that we have written in the last class. I hope every one of you are done revising whatever notes you have taken so far in your book, because you might have written the definition of gravitation, examples, types of forces, acceleration due to gravity, then gravitational law, right? Everything you need to revise in short. So now we need to discuss in short about what exactly gravitation is. Every one of us have some or the other idea on the topic, right? Because we have already discussed it. Let's see what exactly your textbook tells about gravitation. See, we know that the moon goes around the earth, right? We know that the moon goes around the earth and the earth goes around the sun. This is how it works, right? So earth is there and moon is like going to revolve around it. This is again an example of gravitation, right? Then we have that an object when thrown upward. Now whatever you can find beside you, like your eraser, your pen, just throw it upward and you will find out that it will reach a certain height and then it will fall downward again. What will happen? Let's say, what are you doing? You're throwing your object upward. The object will reach a certain height and then it will fall down again, right? So it is said that when Newton was sitting under a tree, an apple fell on him, and the fall of apple made Newton start thinking on this. Why everything is like when thrown upward comes down after a certain time? So this led to the discovery of gravitation somehow. Okay, so what's the story? Newton was sitting under a tree. An apple fell on him, and the fall of the apple on his head, because he was irritated, from he was irritated, and then he was like, why is the apple falling on me? Why is it not going up? Okay, so that led Newton to start thinking on this, and he thought that if the earth can attract an apple, can it not attract the moon? Just think of it, the earth is attracting the apple, because of which the apple falls down on earth. So can this earth, like, can it not attract the moon in that case? Is force the same in both the cases? What do you think? Like earth attracting the apple and earth attracting the moon. What do you think? Will the force be same in both the cases? So he conjured that the same type of force is responsible in both the cases. That force is gravitational force. So in both the cases, an apple attracting the like earth attracting the apple, and like moon, in both the cases same force is responsible. But over here he argued that at each point of its orbit the moon falls towards the earth instead of going off in a straight line. So his argument started through it, and like it was like that the moon falls towards the earth instead of going off in a straight line, so it must be attracted by the earth. But we do not really see the moon falling towards the earth. Can you see, like we all observe moon, it's like very fascinating observing moon in the sky, right? But do you think that the moon fall towards the earth? We never like get this imagined, or we never have imagined this, that moon is falling towards the earth, right? Because that doesn't happen. But there is somehow a kind of attraction that exists over there as well, right? So we'll be discussing that through an example as well. But before that, I want you all to please write some of the points from the screen in your book about gravitation. I hope everyone is taking note of it. Now we have this activity 10.1 to discuss. You can see the boy what he is doing. You need to take a piece of thread. Okay. After taking a piece of thread, tie a small stone at one end and hold the other end of the thread and whirl it around. As you can see the boy is doing, he took a thread, he had tied one stone on the other end and he's whirling it around as shown in figure 10.1. Okay, now while you do so, you need to note the motion of the stone, like in which motion it's like rotating or like how exactly it's moving. And after that, you need to release the thread and again note the direction of the motion of the stone. Okay, so what figure 10.1 states is a stone describing a circular path with a velocity of constant magnitude. What has happened to the stone? The stone is like moving in a circular path with a velocity of constant magnitude. How it's moving? It's moving with a velocity of constant magnitude. Okay, so you can write this thing in your book and then we will start with universal law of gravitation, but make sure you all are going through it. Now after this we have the gravitational law to discuss, which we call it as universal law of gravitation. So now you have to look at the figure properly, and whatever has been explained, that needs to be like looked after properly. Okay, so see, every object in the universe attract every other object with a force. Now if you remember, we have discussed this in part 1 as well, with the formulas as well. Like I have given you, like F is directly proportional to product of their masses, that is M, capital M and small m. If you can see the formula that has been written in the center, where F, that is force, is equal to G, capital G is the gravitational constant. Then we know that it is directly proportional to the product of their masses. So like mass M, capital M and small m is the product of the masses, and it is inversely proportional to the square of the distance between them, right? So the formula that we get over here is F is equal to G m upon d square. So every object in the universe attract every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. Okay, so the forces along the line joining the centers of two objects, where will be the force? The force is going to be along the line that is going to join the center of two objects. So let the two objects be A and B, and the mass of object A is capital M and the mass of object B is small m, and they lie at distance d from the like the distance between them we are going to represent as d, and the force that is acting on the object we are going to represent that as F. So now according to the universal law of gravitation, the force between two objects is going to be directly proportional to the product of their masses. So the mass of object A is capital M and the mass of object B is small m. So product of masses become capital M and small m, and the distance between object A and object B, we represent that with D. And we know that force is going to be directly proportional to the product of masses and inversely proportional to the square of distance between them, right? So it becomes D square, and that is how we get the formula. And remember that capital G, we know that as gravitational constant. So now, according to the universal law of gravitation, the force between two objects is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. And because we are saying it's directly proportional, we get one equation as F, that is force is directly proportional to the product of mass of the object A multiplied by object B. So capital M and small m. Okay, and the other statement that we have is that the force between the two objects is inversely proportional to the square of distance between them. So we can represent that as F is directly proportional to 1 upon d square, because d is the distance between the object A and B, right? So we get this as equation 10.2. Now when we combine both the equation, that is F is directly proportional to capital M and small m, and F is again inversely proportional to square of distance between them, we get this equation 10.3. Wait, right? So this is the equation that we get after combining 10.1 and 10.2. Now even like we can add this capital G, which we know it as gravitational constant. So G is the constant of proportionality, and we call this as universal gravitational constant. What do we call this G as? Universal gravitation constant. And by multiplying crosswise, equation 10.4. This equation gives us, like if we multiply it crosswise, this universal gravitational constant is equal to force into distance square upon mass of the product of the masses. Getting it? So the SI unit of G can be obtained by substituting the units of force, distance and mass, and we get the SI unit of G as Newton meter square per kg square. Okay, so the value of G was found out by Henry Cavendish in the year 17, like Henry Cavendish, he was born in 1731 and he died in 1810, and the value he got was by using a sensitive balance. So the accepted value of G is 6.673 into 10 raised to minus 11 Newton meter square per kg square. Okay, so now we know that there exists a force of attraction between two objects. We are going to compute the value of this force between you and your friend sitting close and conclude how could you do not experience this force. So now I hope every one of you are clear with how we are actually deriving the formula of F is equal to G m upon d square. Now this is very important universal law of gravitation. I want each one of you to please take a note of it properly in your book. I hope every one of you have started writing in. You need to draw the figure as well for proper understanding. I hope every one of you are writing it. Now there are many points on the next slide as well that you need to write, so that make sure that you are like quick with your writing. After this, now you need to write this properly, because this is one of the important answer. Like there are 80 to 90% chances that you can get this answer on universal law of gravitation. So make sure like you are prepared for that. Okay, and that is the reason I'm not hurrying up. Like I'm not in hurry to complete your to complete this lesson. You can make your proper notes, but make sure you are knowing it properly. You should be confident enough with it. I hope every one of you are writing it. You need to write the gravitational constant. What is the value for that? You need to even write the SI unit, each and everything that has been given. So now we have like a short discussion. We'll have a short discussion on Sir Isaac Newton. But before that, I hope every one of you are clear with this part, the universal law of gravitation. I'm repeating it again that this is one of the very important question. Okay, you'll get a direct question. Write a note on universal law of gravitation. So make sure you know it. After this, now we have to discuss on Sir Isaac Newton. So see, Isaac Newton was born in Woolsthorpe near Grantham, England, and He is generally regarded as the most original and influential theorist in the history of the science. So, like many of you might be already aware about Sir Isaac Newton, many of you might be knowing many different things. Okay, so here we have like a small introduction given about him, that he was born in a poor farming family, but he was not good at farming. So what he did is, he was like sent to study at Cambridge University in 1661, because he was not good at farming, so he wanted to study. He went to university in 1661. Then in 1665 a plague broke out in Cambridge, and Newton like took a year off, and it was during this year, like when he took a year off, the incident of the apple falling on him is said to have occurred during this time itself. Okay, so this incident prompted Newton to explore the possibility of connecting gravity with the force that kept the moon in its orbit. So it is this reason itself, because of which Newton started exploring like what exactly is connecting the gravity with the force, because of which the moon is always in its orbit and it's not falling down. So this led him to the universal law of gravitation, and it is remarkable that many great scientists before him knew of gravity but failed to realize it. So there were many scientists who were knowing about this gravitational concept, but what was there, like they were not able to explain the way how Newton has actually explained gravitation. So this became an advantage for him. Okay, so I just want you all to please go through it and then we'll proceed further. I hope every one of you are writing about him and you know how he looks like. Now after this, see, Newton formulated the well-known laws of motion and he even worked on theories of light and color. He designed an astronomical telescope to carry out astronomical observation. This is also one of his invention where he came up with an astronomical telescope. Okay, so Newton was also a great mathematician. Now, when you do your maths part, like you might have studied about Newton there as well, that he was a great mathematician. Then he invented a new branch of mathematics called as calculus, and he used it to prove that for objects outside a sphere of uniform density, the sphere behaves as if the whole of its mass is concentrated at its center. The spheres would behave like the mass of it is concentrated in the center. So what Newton has done is he has transformed the structure of physical science with its three laws of motion and the universal law of gravitation. So now the three laws of motion, we have already studied that in the last class, in the last lesson, right? And here we studied about the universal law of gravitation today. So you have so many things to write about Newton, right? You know many things about Newton now. So as the keystone of the scientific revolution of the 17th century, Newton's work combined the contribution of Copernicus, Kepler, Galileo and others into a new powerful synthesis. So whatever Newton came up with, it has helped other scientists as well to contribute to their work. Okay, so it is remarkable that though the gravitational theory could not be verified at that time, there was hardly any doubt about its correctness. Now, because many things were not available at that time when gravitational theory was put forth by Newton, so though it was not verified, but there was like no doubt with respect to its correctness. Everyone was like finding it correct, and this is because Newton based his theory on sound specific reasoning and backed it with mathematics. So this made the theory simple and elegant. Because of these qualities, they are now recognized as essential requirements of a good scientific theory. So this is all like all about Newton, what he did, how he did, which are the different inventions that Newton has done. Everything has been given over here, and I want each one of you to please write this slide, like write some points from this slide as well. I hope every one of you are going through it. So now in the next class I'm going to start with this example 10.1, where we will be calculating the force exerted by Earth on the moon on the basis of the information that has been provided using the formula of universal constant. Okay, universal law. So we'll be doing this example in the next class. Then we will start with the importance of the universal law of gravitation. Now today we discussed on what exactly the universal law of gravitation is. In the next part, when we start with it, we will be discussing on the importance of this universal law of gravitation. Okay, and after discussing the importance of it, we will discuss on a new concept, that is free fall, through an activity 10.2 in detail. See, as you can see, the activity has been explained over here in detail. So over here as well, if you can see, we came up with the formula for small g. Now small g is acceleration due to gravity. What exactly it is? It's acceleration due to gravity. So we'll be discussing on that as well. Then we will discuss on how to calculate the value of g, that is acceleration due to gravity. So we'll find out that as well. Then after that we have motions of object under the influence of gravitational force of the earth to discuss in detail. We'll do that as well in detail. Then we have example 10.2, 10.3, we will discuss them as well. Okay, and after that we will be discussing on mass in detail, what exactly it is. See, whenever it comes to gravitation, weight and mass, these are two important concepts that is already going to come into picture. So you need to make sure that you know about weight and you know about mass as well. So we'll be discussing on that. Then after that we'll be discussing on the weight of an object on moon. Like let's suppose if you go and land on moon, what will be your weight and how we will be calculating your weight. So we'll be doing that as well, like how can we know the weight of an object on moon. Then we have example 10.4, where we'll be calculating the weight of the earth. Then we have 10.5, where we will be calculating the weight when measured on the surface of the moon. And after that we have another concept as thrust and pressure. We'll be discussing that as well in detail, like what exactly thrust and pressure is. And there are two different situations through which the thrust and pressure has been explained. So we'll be doing that. And then we will be even doing on example 10.6 in detail. Then we have like pressure in fluids to discuss in detail. We'll be doing that as well. Then after discussing pressure in fluids, we will be discussing on buoyancy, what exactly it is through different examples. Okay, then after that we have activity 10.4. We will discuss that as well in detail. Then we'll discuss on why objects float or sink when placed on the surface of water through activity 10.5. We'll discuss that as well. Then we'll discuss on activity 10.6. Okay, then we have the most important thing, that is Archimedes principle to discuss. We will be discussing that through activity. Then we'll discuss on relative density in detail, and we have the formula for calculating the relative density as well. Then again we have example 10.7 to discuss, right? And then we have the summary discussion for the whole lesson, gravitation. We will be doing that as well. Okay. So we have few exercise questions that we will be discussing as well. I just want each one of you to please go through it quickly. हाँ, just I hope every one of you are going through the question. See, we have so many questions to discuss. We'll be discussing them each in detail, okay, once we complete with the lesson. So like I guess there are 22 questions at the end, like which we will be discussing on, okay, and that is how we will be ending up with the whole lesson, gravitation. But I hope that every one of you have understood whatever we have discussed so far today, right? So before we proceed with the next part of the lesson, I want each one of you to revise each and everything in detail properly so that you understand the further topics as well. Now I want, like, I'll be ending up with this part, but make sure every one of you are revising it. Okay? So I'll end up with this part now. Thank you everyone.